Hey guys, welcome to this video lecture series on the subject of polymer science and technology. I'm Harsh Panchal, Assistant Professor in Chemical Engineering Department of LJ Institute of Engineering and Technology. In previous video, we have concluded the addition polymerization techniques. Well, if you have missed that video, you can find it in the I button over here. Now, having said that, let's just move to the next type of the polymerization technique, and that is condensation polymerization. Well, in the introduction part, we have just understand what do we mean by this condensation polymerization. It is nothing but when the polymerization take place, or we can say that in condensation polymerization, the polymer buildup take place through the reaction between functional groups. So you can say that this condensation polymerization technique is all about the functional group, while the addition polymerization technique was all about the double bond and single bonds or more than two bonds. But now in a polycondensation or the condensation polymerization technique, we will be dealing with all the functional groups. So here in this animation, you can say that what is the actual meaning of the condensation polymerization. As you can see here, now this is the polycondensation polymer, right? How it actually make place or how it actually take place. You can see here that these are the two different monomer of a different functional group, and they combine together, or we can say condense together, and liberate a small molecule like this to the outer part, and they ultimately produces long chain of the polymer. So that is nothing but your condensation polymerization, in which two functional group or two monomer having functional group of a different type or a same type combine together, or we can say condense together, to form a long chain of the polymer like this. So now this reaction take place in a stepwise manner. So when this first functional group will react with another functional group, and then after only the third functional group will take place. So we can say that this entire process is taking place in a stepwise manner. So again, this condensation polymerization is also referred as the step condensation, or we can say step polymerization techniques. So this reaction take place in a step manner, hence polymer buildup is a slow process. So again we can say that this entire process is relatively slow because it take place in a stepwise manner. So first reaction will take place, and then after only the second functional group and third functional group will combine together. So this entire process is a relatively slow process. It also accompanied by elimination of a small molecule. You can see here in this animation as well, this small molecule will liberate it out, right? When two different monomer or two functional group combine together, condense together, they liberate a small molecule like this and to form this polymer chain. So this was all about the basic introduction about this condensation polymerization. Well, this condensation polymerization technique can be further classified into two segments as the polycondensation polymerization and polyaddition polymerization. We will see it individually them in upcoming videos. But for now, let's just start with the polycondensation polymerization technique, right? But all in all, you can say that this polycondensation is all about the condensation of two different functional groups, right? Now moving towards this polycondensation polymerization technique, a polycondensation is brought about when two or more reactive functional group condenses together, right? Here in this animation you can see that these are the two different monomer containing two different functional group, right? Here is the first one and here is the second one. So when both the things combine together or condense together, they liberate small molecule of this H2O. You can see here in this animation, this H2O is again liberated, and we are getting long chain of this polyester, right? So ultimately we will having such type of the ester that are nothing but your polymer. Now moving toward the physical example of this thing, let's just consider one small reaction, right? This reaction has nothing to do with the polymerization technique, but it is this simple reaction that we studied in a chemistry. You can see that here I have taken one reactant which has COOH as the functional group. So we can say that it is a kind of acid, right? And on the another side, I have taken one example or one reactant of this hydroxyl group as the functional group. So we can say that this is the alcohol group. So when one acid reacts with the alcohol, it will ultimately produce one ester like this. So you can see that this H from this CH2 will linked with this OH negative ion of this alcohol like this, right? And it will ultimately produce H2O. So let me just take a pen. So this H from this CH2 and OH from this ROH will link together and ultimately produce this H2O molecule. Now what will happen to the rest of the thing? You can see here this RCOO is linked with this RCOO is linked with this R in this way. So this is your nothing but your ester, right? You can see this is your ester, that is RCOOR. Now let me just rub these things so that I can explain you the next concept. Now you can see here that this particular compound, let me just take a laser. Now you can see here this particular compound has a one functional group as COOH, and this particular compound has one more functional group, that is OH. So both the functional group combined together, that we call is the condensation process, condenses together to produce one ester like this, right? But now if you can see this particular component, right, this particular component do not have any functional group, right? It has COOR, and COOR is not an active functional group. COOH is the functional group, but COOR is not the functional group. So ultimately this product formed having no functional group. So it cannot take place further polymerization, or it cannot take part in a further reaction. So we can say that this is the dead molecule, right? But we have to manufacture a polymer. So what should we do? We should have a product which also contains functional group, right? So now it should be noted here that in this reaction, the reactive functional group are consumed. So you can say that these are the reactant which carries functional group. Both the reactant are consumed completely in order to form a product, and this producing an unreactive functional group. So this product will having an unreactive functional group, that is COOR, and hence it cannot take part in a further reaction. So this is not the polymerization, right? It is only simple chemistry and simple reaction. But we are here to produce a polymer. So what should we do? Right? Let's just take one more example so that it will clear more idea about this. Now consider the example of ethylene glycol, that is EG, and acetic acid. Here you can see that this is the ethylene glycol which has chemical structure like this. It has two CH2 it has two CH2 like this, and both the CH2 are attached with the OH. So we can say that this particular compound, that is ethylene glycol, has two functional groups. One is OH and another one is OH here, right? So it can link with two monomers. Now let's move to the acetic acid. Acetic acid is nothing but your CH3COOH. So you can see here this also has one active group, right? So when this both compound will combine together or condense together, they will form ethylene glycol monoacetate like this. You can see here. So this hydrogen from this COOH group will attack on this OH minus group, right? And it will eliminate one H2O small molecule like this. And this entire series, that is CH3COO, will attach to this thing like this. You can see here the product from both the reactant is this CH2OH. This OH is merely attacked by anything and it is staying right as it is, but this OH is now under attack by this COOH group. So you can see that this is the CH2 and here one more carbon is there. Let me just take a pen so that I can draw this thing. Here we have one carbon, that is now CH2COOCH3, right? This is the CH3. So now what is actually happening here? You can see here this OH and this hydrogen is now condense each other, producing this molecule. So this is CH2COOCH. Now this CH2COOCH is not a functional group, right? But this compound or this product still has one more functional group, that is OH. So if we supply one more acetic acid to this OH will again attack with this COOH. Right? You can see here we are going to do same thing. Now this is the same product that we have produced in the last reaction, and we are attacking it with this CH3 COOH, right? Like this. So again this hydrogen will attack on this OH minus ion and it will produce this H2O. And this entire chain, that is CH3 COO, will link with this thing. You can see here, here one carbon is there. So CH2 COOCH3 is now attached with it. So you can see that we are continue to produce polymer, right? In a first reaction, in a first step, we have produced this ethylene glycol monoacetate, and now we have ethylene glycol diacetate, right? So this can be actually happen because this ethylene glycol contains two functional groups. Now you can see here that here one molecule of ethylene glycol and acetic acid is consumed to form monoacetic acid, to form monoacidic ester like this here, right? But still this ester has one active functional group remaining. So one more acetic acid will attack on this OH bond and it will produce this diacetate. But again, you can see here, this diacetate now has no active functional group. So it again cannot take part in a polymerization reaction. But here we are to produce a polymer. So we have to left one more active group on the product. So how we can actually do this thing? Let's just consider one more example so that it will clear the complete idea of this thing. Now let's consider the example of this ethylene glycol, same we have used in the last example. But now this acetic acid is again replaced with this adipic acid, right? So what is this adipic acid? Now we are familiar with this ethylene glycol. It has very simple structure, that one CH2, this both two CH2 are attached with this two OH group on the end side. But what is this adipic acid, right? To understand this, let's just consider this example. Adipic acid is the similar kind of a compound such as acetic acid, but instead of this it has 4 CH2 group. So this particular point represents CH2. This presents CH2. This here we have also CH2 and here we have also CH2. And last carbon has contained this group COOH, and on this side this last carbon also has this COOH group. So now to understand the structure of this adipic acid, you need to consider this point as CH2. So adipic acid has a 4 CH2, 1, 2, 3 and 4, right? The last carbon here is the last carbon is attached with this C double bond C is attached with this COOH group, and here the last carbon is also attached with this COOH group. So on the both end it has COOH and inside it has a 4 CH2 carbons, right? And here we have one ethylene glycol. So ethylene glycol is again simple CH2 and at the end it has OH and here it also has the OH. So now we are taking two molecules of each thing, right? Two molecules of adipic acid and two molecules of ethylene glycol. So now let's see what happens here. So now as we can accept that this COOH group will leave this hydrogen from here and it will link with this OH minus from this ethylene glycol and it will produce one H2O group. So both the monomer will combine together, or we can say condense together via this functional group, leaving like producing the product like this. You can see here we have COOH in this end and these are the 4 CH2 of this adipic acid, right? Now this last carbon is attached with this COO and the chain of ethylene glycol. You can see that this is the chain of ethylene glycol, in which here this is the CH2 and lastly we have OH. Now you can see that this particular atom has a 2 active group left at the end of it. Here we have one OH and here we have one more OH. This represents this product can undergo further polymerization reaction. So if we continue to add one more monomer of this ethylene glycol, it will again react on this side with this OH and ultimately producing one more polymer. And that polymer will also have OH group at the last carbon, right? So we can say that now we have produced a chain of the polymer which will look like this. You can see here, this is the polymer formed with the adipic acid and ethylene glycol in a number of times, right? So we have represent N like this. So this is your polymer produced from the adipic acid and ethylene glycol. Consider the reaction between two molecules of ethylene glycol and adipic acid each. So one molecule of each component react to produce or form the monoester product like this. This is the monoester product, right? Here you can see that this adipic acid is reacted with this ethylene glycol and we have understand this, it is produced one monoester. Now this product still contains two active functional group at OH minus and COOH. You can see that here we have COOH and at this end we have OH minus, so that it represents that this particular product can further undergo the polymerization reaction and it will ultimately produce long chain of the polymer. So if we take N molecules of this adipic acid and ethylene glycol take part in this polymerization reaction, we will get the polymer which can be represented in a general like this, right? So if we have taken N number of reactants, that is adipic acid and ethylene glycol, we will have long chain of the polymer like this. Here you can see that they here you can see that this is the particular monomer of the ethylene glycol which has CH2CH2. One is attached with the OH group while the another monomer is attached with the COO group of the adipic acid. So here this COOR is the adipic acid. Here we have 4 atoms of CH2 and lastly it is attached with this COOH, right? And it will ultimately produce n number of H2O as well. So this was all about the polycondensation technique. I hope by now this polycondensation technique is being clear to you. It is basically nothing but condensation of a two or more than two functional group in order to produce long chain of polymer. And we have understand it with the classic example of adipic acid and ethylene glycol, which ultimately result in the long chain of the polymer, right? Now let's just understand some important remarks of this polycondensation polymerization technique, right? The first important thing in this polycondensation technique is that the monomer should have two reactive functional group for the polymerization to proceed. So if there is a less than two functional group, then polymerization technique will fail, right? So in order to produce a long chain of polymer, the functional group should be more than two, such as ethylene glycol or adipic acid, right? With the help of alcohol or acetic acid, we cannot produce long chain of the polymer. So now the second point is that the polymerization proceed by stepwise reaction between reactive functional groups, right? So this polymerization technique, specifically polycondensation, is this stepwise process, right? So when two functional group, either it can be COOH, OH, or it can be amine, combined together, condensed together in a stepwise manner. So the third important point is that only one type of the reaction between two functional group is involved in the polymerization formation. So there is only one single type of the reaction is being allowed in the polycondensation. So here that reaction is the condensation reaction. So now the last important point is that polymer formed still contain both reactive group and it at its end. So as we have already seen that at the end of the chain it also contains the functional group. That means it shows that this polymer can also undergo further polymerization reaction and it can also produce long chain of the polymer. So this was all the important remarks which are very easy to understand in the polycondensation reactions. Now in the next video we will be focusing on the addition polymerization techniques. We will see you in the next video. Till then, keep watching, keep learning. Thank you.